Hello, dear students. We are back again, and we reach in chapter four, chapter 4, section 1. We have finished chapter 3, and now we reach chapter 4, section 1, which is the topic. It's about the temperature and heat. Now, we are going to be explaining what is the difference between temperature and heat. What is temperature and what is heat, and what is the difference between of them? Okay, so first of all, temperature definition is measure of the average kinetic energy in a substance. Students, when we have any of the particle, or we have, for example, we have this container. If this container consists a lot of particle, then we are going to give this. We are going to make this container. We want to increase the temperature of this container. The temperature of this container. To increase the temperature of this container, the particle inside this container, they receive this energy, this temperature, and the temperature of the particle is going to be increased. When the temperature of the particle is going to be increased, after that, each of the particles are moving randomly inside the container so quickly and fast. So, for example, look, this is the particle in here inside the container. When we are going to give this container heat, this particle inside the containers, we have a million particles, and when each of the particles they are receiving this heat, this energy, after that each of the particles are moving so quickly, their kinetic energy, because they receive a lot of energy and they are moving so quickly. So it means that, that's why the definition here, it said measure average kinetic energy of a particle in substance. It means if we have more temperature, it means that the kinetic energy of the particles getting increased. When the particle they receive a lot of energy, the kinetic energy of the particles is going to be increased. They are moving quickly like that because they receive a lot of energy. So this general, the relationship between energy or temperature and kinetic energy of the particle directly proportional. When any of the substance they are receiving a lot of energy, it means their kinetic energy going to be increased. So this is the general temperature. So look, even though in here I wrote for it, the temperature is also proportional to the kinetic energy that of the constituting atoms and molecular matter. When we have a lot of particles, each of the particles kinetic energy are directly proportional to the temperature. When this particle they receive a lot of energy or temperature, the velocity, the kinetic energy of the particle is going to be increased. They are moving very fast and quickly because they receive a lot of energy. So that's why if there is more temperature, more energy, there is more kinetic energy of the particle. We have so now we understand what's the temperature, but what's heat? We have to know what's the meaning of heat. I think here we have heat. Meaning of heat. What's the difference between heat and temperature? Baba, look, heat. First of all, heat is energy. Energy transferred between objects because of difference in temperature. For example, if we have two objects, this is the first object and this is the second object. The temperature of the first object is 10 Celsius, but the temperature of the second object 2 Celsius. Because both of the object temperature are different. So the first one 10 Celsius, the second one 2 Celsius. In that case, you have transferring energy. This transferring energy, this is called heat. You have to make a difference between heat and temperature. We said temperature is the measured kinetic energy of the particle. temperature is the relationship between getting energy and the temperature of each object going to be increased. It depends on the energy that we are give the object. But heat, no. If there's two objects, if there are two objects and they are both of them different in temperature, in that case you have transferring energy from the higher temperature to lower temperature. What if there's no different in temperature between of them? For example, both of them 2 Celsius, 2 Celsius. So in that case, we don't have any transferring energy. We don't have any transferring energy. The heat transferring in that case, equal to 0. But in here there is transferring energy because both of them are different temperature. So energy transferring between objects when they are in different temperature. So actually this is a difference between of them. When we have an object, when this object, for example, if you have two objects and both of the objects they have a different temperature, in that case there is transferring energy between of them and from the higher temperature to lower temperature. But if both of the objects they don't have same temperature, sorry, they don't have a different temperature. I mean both of the objects, if they have same temperature, not different, if both of the objects are equilibrium temperature or both of them are identical, same temperature, in that case there is no transferring energy. So this is called thermal equilibrium. Thermal equilibrium, look, a state in which two bodies in physical contact. Then for example, look at my hand. This is the first object and the second, and both of them are in contact. Both of them are in contact, but both of my hand they have same temperature. So in that case, there is no transferring energy. So we have two objects. First object, second object, both are in contact, but still there is no transfer energy because both of my hand they have same temperature. So that's the state when two body physical contact and have identical temperature. Okay. What does the object temperature depends on what? Now I told you that the temperature of the object depends on what? It depends on the average kinetic energy of the atom. If you have more temperature, it means the kinetic energy of the particles they are moving, or their velocity is very quickly fast because we have more temperature. I told you the relationship between temperature and kinetic energy is directly proportional. What is the unit of temperature in SI unit? Kelvin, of course. We have one of the device which is called thermometer. Thermometers device are using for measuring or detecting the temperature of each object. This device we can find the temperature of each object by using this thermometers device. Good. Now we have this relationship. I think you have studied even though in grade 9. This relationship between converting unit Kelvin and Celsius, TK, which is equal to TC plus this number. You should memorize it because we have example to solve it later. We have this question: what must be true of two objects if the objects are stayed in thermal equilibrium? Every time when we have thermal equilibrium, I told you it means there is no transferring energy between the object. Why there is no transferring object among of them? Because both of the objects they have same temperature. So if there's same temperature, there is no transferring energy. When we have transferring energy, as a heat, when both of the objects they have a different temperature. For example, I told you if the first object temperature 46 Celsius and the second object is 25 Celsius, because both of them they have the same temperature, and of course in that case we have transferring energy as a heat. From which side? Left, right, or right to left? Actually from left to right. You know why? Because this object has a greater temperature compared to that one. So we have transferring energy from left to right, because 46 is greater temperature they have. it has a greater temperature, so every time transferring energy from the higher temperature to a lower temperature. Okay, I think I forgot the questions on here, or I told you all of them. Okay, good. What is the difference between heat and temperature? I told you now, heat is energy, Baba. Heat, it's energy and transferring between objects because of different temperature. But temperature, no. Temperature is measured over a kinetic energy of the particle. And the unit of heat is joule, because heat is energy, and the unit of every type of energy every time is joule. The unit of all of the type of energy every time is joule, but temperature is Kelvin. This question is important actually. How energy in the form as heat transferred between objects? I told you, energy transferred as heat always moves from a higher temperature to an object at a lower temperature. As you can see in here, from the higher temperature to a lower temperature. So students, let me tell you one thing that it's left, the process of transferring energy and when it reaches to thermal equilibrium, and how is the transferring process, how is the transferring energy can happen. Look, this is an object, as I told you now. For example, temperature is 45 Celsius. And this is the second object, for example, 20 Celsius. Because both of the objects are different in temperature, so it means in that case they are transferring energy between of them, because both of them has different temperature, from left to right. Transferring energy from left to right. Okay. The first is 45 Celsius and the second one 20 Celsius. There is transferring heat as energy. Both of the objects, they are transferring energy from left to right. You know what's the meaning of transferring from left to right? It means this object, the second object, they are receiving energy from the left side. After a few minutes, maybe the first temperature it become decreased. Maybe it becomes 40, but the second one get more energy. It's become maybe 25 Celsius. Why? Because as I told you, you have transfer energy from left to right, and the right side of the object, they are getting a lot of energy from the left side, because the left side, they give a lot of energy, they give a lot of their own energy to the right side, and the right side, they are receiving this energy. So look, the right side temperature is getting increasing. So this process, it keeps moving. Actually, this process, it keeps continue until both of the objects, they are reaching to the thermal equilibrium. For example, look, after an hour, for example, again, the first temperature will become maybe 31 Celsius, and the second temperature, maybe it reached to 29 Celsius. Look again, the first object, their temperature still become decreased. Their temperature is going to be reduced. Why? The temperature is reduced because we have transferring energy from the left to right. They are transferring the energy from left to right. They give their own energy to the right side. So the right side, they are receiving energy. That's why, look, if you notice that in here, first it was 20. The second becomes 25. Then it's become 29 Celsius, But the left side temperature getting decreased, but the right side getting increased. Maybe After a while, we see that in here, after a few minutes again, this temperature become 30 Celsius, and the other temperature still has become 30 Celsius. The temperature 29 become 30, increase it, but this one 31, because they are giving energy, become 30 Celsius, again become decrease it. But in that case, if you notice that both of the energy, they have same temperature, 30 Celsius. In that case, we don't have any transferring energy. Transferring energy, heat, becomes zero, because where was the first step, the first process? The first process, it was in here, 45 Celsius, 20 Celsius. There was transferring energy because we had a different temperature. This process keeps moving, it keeps continuing until it reaches in that state. The second object, they are receiving energy, but the first object, they are losing their energy. After a while, we see the second object become 30 Celsius, but the first object is still 30 Celsius. In that case, both of the objects, they have identical temperature. So this step is called thermal equilibrium. Thermal equilibrium. So thermal equilibrium, how we can get this step? It reaches in that step when the object, it starts to transfer energy from the beginning in here, then it reaches in that step at the end. There wasn't any energy transfer between of them, so because both of them are same temperature. So this is the process actually I'd like to tell you. So now I hope to understand. Okay, so we said the transfer energy from the high to low. We have another part in here which is called internal energy. Internal energy, the energy of matter due to random motion of its molecule, and is the total energy of this molecule. Internal energy, internal energy, every particle, or we can say every object, for example, this pen, let me bring example like that. This pen, it consists a lot of particle. It made up of a lot of particle and molecule and atom. Each of the particle, each of the atom, each of the molecules, they have energy. So, and this energy, it's called internal energy. By the meaning, we can say, for example, this is the object. Inside this object, we have a lot of particle and molecule. This is object, right? Inside this object, you have this particle. So the energy of each of the particle, this is called internal energy. Internal energy. By the name of the meaning, we can understand. The energy of inside of the object is called internal energy. So, even though the definition said the energy of matter due to random motion of its molecule. Each of the particle, they are moving with they have their own motion. So the motion of this particle inside this object is called internal energy. So if you remember in the previous video, or I think now I told you how to increase the kinetic energy of each of the particle inside the object. I told you we can give this object heat or any type of energy, for example heat. Each of the particle, they are receiving this energy. Each of the particle inside this object, they are receiving energy. So the temperature of each of one of them going to be increased. When the temperature each one of them going to be increased, it means the kinetic energy of each of the particle going to be increased, and they are moving very, very quickly. The kinetic energy of all of the particle, it become increased. Because why, mister? Because we give this object energy, heat, and the particle inside of it's going to be increased. When the particle inside they are receiving energy, it means the internal energy going to be increased. So look at the relationship. This is heat. Give the object heat. Then the kinetic energy of the particle going to be increased. Then the kinetic energy of velocity or the speed, all of them same. then the internal energy still going to be increased, because all of them, the relationship is directly proportional. First, give this object heat, then the kinetic energy of each of the particles going to be increased because we give them energy. Then the internal energy going to be increased. You know why the internal energy going to be increased? As the definition said in here, look, the energy of the matter due to random motion of its molecule. Random motion. Of course, when you are giving this object heat, the particles motion going to be increasing randomly. Of course, the internal energy going to be increased, because internal energy, it means the energy or the motion of the particle inside this container. So the particle is going to be increased in energy because we give them energy, and this is the relationship actually. So this, in general, this is the meaning of internal energy. Internal energy, that the motion of the molecule of the atom that consists inside any object, their motion, their velocity going to be increased when you are giving this, when you are giving heat to that object. The object particle receiving energy, and their energy and their motion or the kinetic energy going to be increased. Good. So we have now some technique how we can increase the internal energy of any of the object. We have actually some of the technique. First of all, by deforming. By deforming, for example, we have this pen. If I make a lot of force on it, a lot of pressure on it, maybe this pen is going to be broke. It get broke then, right? It gets maybe this pen's structure is going to be changed because I apply a lot of energy or a lot of force on it, because this pen, it consists a lot of particles. I apply a lot of force on it, so the particles structure going to be changed, and they are getting a lot of energy. So by deforming structure, when a rubber is bent, stitched, for example, we have a rubber, for example, you are stitched like that, or compress it, or applying any of the force in any of the directions, if the structure of this particle is going to be changed, and the kinetic energy and the internal energy still is going to be changed. In here we have a bottle of water shaken. We have a bottle, and inside the bottle fully by the water, and you are shake the bottles like that. The internal energy of the water will change, of course, because you are shaking the water, and the water is inside the bottle. And yes, shaking of the bottles add what? If you notice that when you are shaking the bottle like that, the kinetic energy of the system become changed and increased, and its kinetic energy then it becomes internal energy. In general, how to convert or how to increase the internal energy of any object? You can add force, add pressure, or you can change, you can deform, you can change the structure of this object. For example, this pen, as I told you, can make a force like that, and it become brooks, or any of the direction. You can apply force, or rubber, stitch it, compress it. All of those things that you like to do, it can affect the structure of the object. Then the internal energy is going to be increased or change. This table important. We have the unit of heat. The unit of heat in SI unit. Look, Baba, this is the SI unit of heat is joule every time. But we have two units of heat. One of them, it uses for SI unit. The SI unit of energy or heat every time is joule. But we have another unit of heat which is called calorie. This calorie, this is right, yes, is the unit of heat, but it's in non-SI unit. Non-SI unit. So this is the unit. This is the unit of heat. The unit of heat in non-SI is called calorie, but the unit of heat in SI is joule. Good. So there are two type of unit. We have two type unit of heat. The first one, joule, that you are using this in SI unit, but the other one, non-SI unit, which is called calorie. Okay. We have conservation of energy. Conservation of energy, I think even this definition you have studied in grade 9, the definition. This conservation energy, the definition said, energy can neither be created or destroyed, but can change from one form to another. What's the meaning of this actually? It means we cannot create energy by ourselves and we cannot destroy it, but we can change from one form to another. How? We explained now this. If we have these two containers, one of them, for example, 10 Celsius, but the other 2 Celsius, huh? We studied this now. And I told you, for example, if we have different temperature, of course, we have transferring energy from the left to right. Left to right, this is heat transferring from left to right. What is the meaning of this? It means energy can change from one state to another, can change from one form to another form. The energy can change or can transfer, but we cannot destroy this energy. We cannot create energy even though by ourselves, but energy only can change from one form to another. We have now two quantity that's so important, which is called kinetic energy and potential energy. Kinetic energy is important, even though again you will study in grade 11 and 12. Kinetic energy rule, which is equal to 1 over 2 mv square, and potential energy, which is called mgh. But kinetic energy in physics, even though I told you in the previous video, how to understand what's the meaning of kinetic energy. Look at the rule equation. We have what? We have mass and velocity. So kinetic energy of any of the particle, it depends on the mass of the object and the velocity. For example, any of the person, for example, this person, he or she has a kinetic energy. It depends on his mass or her mass and his velocity and her velocity. If the mass of this, for example, this boy, for example, it's 100 kilogram, and if the velocity of this boy, for example, 10 meter per second, it means even though we can find kinetic energy, because 1 over 2 is stable. We have the mass of the object of this person, and even though we have the velocity too, we can find the kinetic energy of this person, of this boy, or anything, any object. So kinetic energy, it depends on the mass and the velocity. If any object, it has more mass, it means it has more kinetic energy, or any of the object, it has more velocity, it means it has more kinetic energy. So the relationship between kinetic energy with mass and with velocity are directly proportional, with both of them going to be increased. And if you have more mass, it means you have more kinetic energy. If you have more velocity, it means you have more kinetic energy too. Of course, good. So kinetic energy, it depends on two quantity, mass and velocity. Now we have another thing which is called the potential energy. This is called potential. What is potential energy? Potential energy is the energy of any object that they have their own energy. For example, let me tell you the rule, kinetic potential energy, which is equal to mass times acceleration and times height. This is the mass of the object, and this is the acceleration, and this is the height. Acceleration, which the number every time stable, 9.81, and this is the height. Again, potential energy, like the kinetic energy, it depends on two quantity. G acceleration every time it's constant, okay? So potential energy can depends on two important quantity, which is called mass and height. Look, for example, we have this tower, and there's a person staying on the top of this tower in here, okay? And this is the ground. This person and he or she staying at the top of this tower. And we have another person, he or she staying in the ground and the bottom of the tower. So we have two persons. One of them they are staying on the up, the other in the down of the tower. Which one of them that they have more potential energy? Actually, I told you potential energy. It depends on what? Depends on the mass and height. Especially height important. Look, first of all, we have to compare which one of them that has more height. It means has more potential energy. Yalla. This person that he's staying on the top of the tower. Compare. This is the person and the height. This person, he has height, and this is called h. This is the height of this person. But this person that he is staying in the bottom of this tower, he's staying at the bottom of in the ground in here. He doesn't have any h, so the h in here is 0. Which one of them has more potential energy? Actually, this person that he's staying at the top of the tower, because this person that he has h. Look, he has h. Maybe the height, for example, is 100 meter. We have this height, this h. This person, he has height and has h. In that case, because this person has h, it means this person has potential energy. But that one, he doesn't have any h because he's staying at the bottom of the tower. He's staying at the ground. So here there is no h. H is 0. So it means this person, they don't have, or he doesn't have any potential energy. So which one of them has more potential energy? That person, because he has height. As I told you, potential energy depends on two quantity, mass and height. Especially height important. If any object has height, it means has potential energy. If any object it doesn't has any height, it means that it doesn't has any even though potential energy. So potential energy depends on mass and energy, but kinetic energy it depends on mass and velocity. Good. I wrote in here all of them. You can screenshot this factor and note. Now we are going to be solving some exercise. And here we have this example to solve it. This example, we have this device. Actually, Baba, look at me. We have this device, and this device used to increase. This device, we are using this device actually to increase the kinetic energy of the particle. These devices are rotated like that, and we have this panel. Actually, this is called panel, I think. This panel going to be rotated like that, and this rotation it can affect the particles, and the rotation it becomes like it can affect the particles, and this is the result. It becomes to increase the kinetic energy of this object. So look in here. Actually, we have mass 11.5 and it falls 1 meter. There's a distance, and then all the mechanical energy is converted to internal energy. How much all the internal energy are they going to be increased? One of them it's suspended by this mass. This mass it takes some distance. It falls down. It comes down, takes some distance, and the distance is 1.3 meter. This is the distance of each object that is suspended with this device, and it falls down when during the device it works. This mass it falls down. When this mass it comes down immediately, this panel, I think it's called panel. This panel is going to be rotated like that, and it can increase the internal energy. Okay. Uh, Now we are going to be solving. The question said how much will the internal energy, it means find the internal energy. This is called paddle. A vessel, it contains a water that paddles are propelled by falling mass, it turned in the water. This mass, it falls down and the paddle is going to be rotated like that. It can this become increasing and this can affect the device to increase the kinetic energy of the particle. Anyway, how we can find the delta U or internal energy? I forget to tell you the symbol of the internal energy. We can name it like that. We can write it like that, delta U. Delta U means internal energy. So how we can find delta U? Delta U every time, delta U which is equal to mgh. Okay, delta U every time which is equal to mgh, and you have the mass of this object which is called 11.5 times, and the g acceleration 9.81 times, and h, the height, it means the distance when the mass it falls down. It was I think the number 1.3. Yes, look, this is 1.3 meter. You can times both of them, and the answer which is equal to 147 joule. Be careful, joule. Why joule? Because delta U is internal energy. The unit of internal energy, kinetic energy, potential energy, any other type of energy, every time is joule. So now we are going to be solving some of the examples in here that we have. Question one, we will not solve question one because it is related to this example that you have solved, but it's same thing. Question two. Be with me to solve question two. A worker drives 0.500 kilogram spike into a rail tie with a 2.5 sledge, a hammer. Okay, you know what's the hammer? In Kurdish, hammer, it means chakush. Hammer. Even my drawing picture handwriting is bad, okay? But still I'm going to draw the picture. This is the shape of the hammer, for example. For example, this is the hammer's picture. For example, this is the hammer. Okay, and this is the hammer, and this is the hammer. This is the mass of the hammer, which is equal to 2.5 kilogram. And we have spike. Spike, it means bismar. We have spike. Look, this spike, for example. This hammer, it hits the spike with the velocity. Hits the spike with the speed. The speed which is equal to 65 meter per second. Okay, then this is the speed, 65 meter per second. The question here it said if 1/3 hammer's kinetic energy convert to internal energy. This is important. 1/3. 1/3 it means 1/3. 1/3 it means 1/3. 1/3 what? 1/3 hammer's kinetic energy, and 1/3 kinetic energy which is converted, it means equal to what? Internal energy. We are going to use this rule, important. I'm going to repeat again. Look, if 1/3 and 1/3 kinetic energy hammer, and hammer's kinetic energy, it means Ke, 1/3 Ke converted. We have converted, it means converted, it means changing into internal energy, and equal to the internal energy delta U. So the question said how much the total energy increase. So find delta U. Find delta U. And delta U, we can arrange the question delta U which is equal to 1/3 kinetic energy. يلا delta 1 over 3 times. What was the rule of kinetic energy that I told you important? Instead of kinetic energy, write down the rule. It was 1 over 2 mv square, right? So 1 over 3 times 1 over 2 will become 1 over 6 times mv square. Most of the students, they are mixing this question. Mr. I don't know, I have to write which of the mass, since in here we have two mass actually. The mass of the hammer, which is 2.5, and the worker drives 0.5 kilogram spike. Actually in here we have to write down the mass of the hammer. The reason is because we are working on the hammer. The hammer hits this spike with this velocity. So of course you have to actually write down the mass of this hammer. So the mass of the hammer 2.5, I think, yes. 2.5 times, and the velocity of the hammer while hitting the spike 65 and square. This become easy action. Only use calculator, square this and times by this, and the result divided by 6. You can get the internal energy, which is equal to 1.76 times 10 power 3 by joule. Internal energy every time joule. That was an important question actually. Okay, question 3. We have another questions. Question 3. Question 3. 3 times 10 power negative 3 copper penny drops a distance. When you have a money, we are throwing the money to the up and take a distance. So in here first we have the mass of the penny, which is equal to 3 times 10 power negative 3 kilogram. Then a penny drops a distance. It takes a distance. This is 50 meter. So distance, it means h, height. So h, which is equal to 50 meter, the distance or the height to the ground. Look, this sentence is important. If 65% of the initial potential energy, if 65% potential energy goes into increasing kinetic energy, it means in general, if 65% of potential energy, it changes to internal energy. If 65% of the potential energy, it goes increasing internal energy, it means changing to internal energy. Okay, determine the magnitude of that increase. And again, find delta U. Find internal energy. So first of all, in here, 65%, it means 65 over 100. So 65 over 100, we can make it a decimal number. It becomes 0.65 times. And instead of potential energy, I told you the rule. What was the formula or the rule of potential energy? It was mgh, which is equal to delta U. So 0.65 times the mass of the pin in here, it was 3 times 10 power negative 3 times g, acceleration, it was 9.81 times, and the height when you are throwing the pin to the up, it takes some distance. The distance, the height, it was 50 meter. You can multiply all of them and delta U again by joule. The answer becomes 0.96. 0.96. Good. Question 4. Question 4. The last question in this part. This question important, I think. Good question. The amount of energy needed to raise the temperature. The question said what? The amount of internal energy the amount of internal energy needed to raise a temperature of 0.25 kilogram of water by this temperature is 209.3. And here we have the value of internal energy. So delta U, which is equal to 209.3 joule. The question said, just read the question please. The amount of internal energy, which is equal to what? 296 joule. The question said how fast يعني speed, find the speed, how fast, find the speed V, how fast must a 0.5 kilogram baseball travel in order its kinetic energy equal to this. This is important. Kinetic energy, which is equal to internal energy, we have to use this relationship. Kinetic energy, which is equal to internal energy. So look at me. The question said find velocity. Okay, what was the rho of kinetic energy? It was 1/2 mv squared. And where is the delta U energy? Actually, the question they gave us the value of delta U energy, which is equal to 209.3. So we have the internal energy in that question. But the question said find velocity or find the speed. And instead of kinetic energy, write down the rule. So in here, if you notice that we have velocity, we have the speed. So we need to find this speed. It's become easy actually. But first of all, because in here we have fraction, you can times both sides by 2. Multiply both sides by 2. So this 2 will be cancelled, and only mv squared is left. Mv squared, which is equal to this number, 209.3 times 2. Then we need to find the speed. How we can find speed? Next to speed you have mass, so divide both sides by mass. The mass going to be cancelled, so velocity squared, which is equal to this number in the up, 209.3 times 2 over the mass. And here we have to write down the mass. In here, but which mass again? Do not do mistake. Actually, in here we have both of them same thing, but you have to write down the mass. Both of them 0.25. So still the mass still will be the same thing, 0.25. But first of all, you have to times this and divide it by 209.3 multiplied by 2. The result divided by 0.25. When you get whenever you get any answer, you have to take a square root, because in here look we have speed square root. So you have to take a square root. Actually, I don't have calculator, that's why, but it's still easy. Multiply both of them and divide by this number, then take square root. The answer will be 41 what? Because we found velocity or speed, the unit of speed, meter per second. Okay, question 4 done, finish. In here we have some question. Question 3, we explained question 3. If we have a bottle shaking, the internal energy going to be increased. And question 2, question 2 and question 1, only question 3 important. Question 1 and 2 you can skip it actually. Now we reach chapter 4 section 2. We have another topic which is called changes in temperature, and this topic is called specific heat capacity. Specific heat capacity, let me explain actually on this whiteboard. What is specific capacity in general? In physics, I told you have to understand three things. First, the rule. What is the rule of specific capacity? Cp, it means specific capacity, which is equal to Q over M delta T. This is the rule, the general important or the famous rule in this section 2. This is the formula of specific capacity. Specific capacity, which is equal to Q over M delta T. Q, we started in section 1, if you remember. Q, it means heat, transferring heat. If you remember, we said you have transferring heat between two objects. So the symbol of heat, we can name it like Q. So the Q, it means energy. The symbol, it means energy, Q. M, it means mass. And delta T, because we have this triangle, it means changing in temperature. Changing temperature. Okay. And now, the first thing I told you, we have to know the rule of each of the equation that you have in physics formula. Now, I told you, and we did, this is the rule of specific capacity. We have the relationship between energy, mass, and delta T, changing in temperature. Then the definition. The definition said the quantity of energy to raise the temperature of 1 kilogram substance by 1 Celsius at constant pressure. The quantity of energy needed to raise, look, in here, for example, we have this object. The temperature of this object, for example, is 10 Celsius. I will give heat. I'm going to give energy to this object. I'm going to give energy to this object, heat. Okay, give energy to that object. We want to increase the temperature of this object only by 1 Celsius. But if the mass of this container, this object, is 1 kilogram, the mass of this container 1 kilogram, and I only want to increase the temperature of this object by 1 Celsius. For example, after when I give this object heat, the temperature of this object after it becomes, for example, 1 Celsius, of course become 1 Celsius because I decided only to increase the temperature by 1 Celsius. So let me repeat again. We have this container. The mass of this container 1 kilogram. And even though I want to increase the temperature of this object by 1 Celsius, the temperature after a while become 11 Celsius, still the mass is 1 kilogram. So this is called in general specific capacity. When you have an object, the mass of the object 1 kilogram, and you want to increase the temperature of this object only 1 Celsius, so this process called specific capacity. Look, same thing. Heat, this is the heat. Of course, I give this object heat. And this is the mass. The mass is 1 kilogram. This is the temperature. This is the temperature. This is the heat. This is heat. I give this object. I give this object heat. I give this object heat. And this is the mass of the container, 1 kilogram. And this is the first temperature, Ti. It means the first temperature, 10 Celsius. After a while, we see that the temperature is changed. It changes. It becomes 11 Celsius because I increased the temperature, I told you, by 1 Celsius. And this is the mass again still. This process is called specific capacity. يعني increasing the temperature of each object or any object, increasing the temperature of this object by 1 Celsius, this is called specific capacity. Let me tell you on this rule, on this equation. Increase, give the object energy. Give the object energy. Okay, I give the object energy. And the mass of the container 1 kilogram, of course. and this become changing in temperature by 1 Celsius. This process is called specific capacity. Let me repeat again. We are giving an object heat. I give the object heat, and we have the mass stable, constant, still 1 kilogram. And after, when we are giving the object, when we are giving heat to that object, the temperature of the object become change in temperature. This process called specific heat capacity. I hope you understand in general. Okay. And I forgot to tell you one thing. This is the, let me write down the rule again. Cp equal to Q over M delta T. This is the heat, and this mass, and this is the change in temperature. We have question in here. What the specific capacities depends on what? Yani Cp, it depends on what? Actually, we can find a factor that can affect of any of the object in physics only by the rule. The rule in here we have Q, M delta T. So the factor that can affect is Cp first, energy يعني heat, or Q. Because how we know Mr. Q, energy heat? Because according to the rule, you have energy heat. Look. The second one, mass of the object, or only write down mass, the mass of the object. The last one, changing in temperature, or delta T. Changing delta T. So Cp, the factor that can affect Cp, Q delta T mass. And now, only by the rule, we can make a relationship. We can, even though we can explain only by this rule. We can make a definition by ourselves. For example, Cp is a relationship between, we are giving the object heat and the mass of the object 1 kilogram, and after a while we would like to increase the temperature by 1 Celsius, it become change in temperature. So this process is called Cp. And what things can affect Cp? Energy, mass, delta T. According to this rule, Cp, which is equal to Q over M delta T, I need, or I want to find energy Q. How we can find energy? Write down Q energy, write down this Q energy in here. We see that only these parameters quantity are left. You can multiply both of them together. Cp times M times delta T. So to find energy, we are going to multiply both of them. Cp times M times delta T. So you have another question. We know Q, it means heat. So what does the energy, this energy we have explained in section 1. Heat, it means transferring energy between two objects, right? So this energy that is transferred as a heat, it depends on what? Actually depends on three things again. Cp, because in here we have Cp. The second one, mass, because in here we have mass of an object. The last one, delta T, changing in temperature, because energy heat, which is equal to these three parameters. So of course these three parameters can affect heat. This is in general the idea about this section. This is we said now what the specific heat depends on what, and energy depends on what. We said all. And this is the rule actually, huh? Same thing. Specific capacity, it means Cp, which is equal to energy transfer. Energy transferred as a heat, yani Q, mass, and changing in temperature. And how we can find Q? To find Q, even now I told you Cp M delta T. And this is specific capacity's definition. We have another question. When does Q and delta T be positive, and when it be negative? When the temperature increase, when does Q, and when does Q heat be positive and delta T be positive, and when it be negative? When the temperature of an object become increased, delta T and Q, both of them become positive, increased. But when the temperature decreases, delta T and Q energy become decrease it or become negative. Actually, this table, it doesn't necessarily to understand or to memorize it, I mean, because this is the specific heat capacity for each of the substance. Specific capacity, for example, aluminum, gold, ice, iron. So it doesn't necessarily actually to, because the teachers, all teacher, they will give you in exam the number. And I forget to tell you one thing: the unit of specific capacity important, joule over kilogram times Celsius. How we know that this unit is become joule over kilogram over Celsius? If you remember, I told you now, by memorizing only the rule, even though you can make a definition, you can get the factor, you can understand, make explanation by yourself, and even though by memorizing the rule of specific capacity, we can even though find or get the unit of specific capacity equal to what? What is the unit of specific capacity? First of all, look, the unit of heat energy we know, joule, and the unit of mass is kilogram, and the unit of delta T. Actually, delta T changing in temperature in SI unit is Kelvin, but in this section, because we are solving example, every time it becomes Celsius. So that's why the unit of specific capacity, which is equal to joule over kilogram times Celsius. What is calorimeter? Calorimeter, if you remember the section 1, we have studied thermometer. I told you thermometer is a device for finding or measuring the temperature. So this is the same thing, but this is calorimeter. Calorimeter is a device that is used for measuring CP or for measuring specific capacity. By this device or according to this device, we can find the specific capacity of each of the substance. Okay. In here we have some. In here now we reach to solve the example actually, but I'm not sure that we have time to solve. Let me check how many questions that are left. Okay, so for the next video, inshallah, we reach in this page, we reach here. So inshallah, for the next video, we will explain this part. Thanks for watching.